Hello and greetings, SpinSucks community. Mike Connell and Jenny Dietrich asked if could spend a little time talking today about what Mike calls the dummy's guide to data. We'll be a little more charitable and talk about the data lifecycle. My name is Christopher Penn. I'm the co-founder of Brain Trust Insights, a data science consulting firm. Have a lot of experience from past years in public relations, working at a PR agency for about 5 years, a little more than 5 years, and now sort of out doing my own thing. But I want to talk today about how you can make better use of data and how to think about managing data, how to think about processing it, and the cycle that you should go through with your data to make it more useful, because data is the foundation of great business, of analytics, of developing good insights that move the needle for your business. And it's going to become increasingly important as more of the world turns to machine learning and artificial intelligence. A brief aside, artificial intelligence and machine learning are all about taking data and turning it into software. Traditionally, when you fire up, say, like your word processor, you have an app that's software, and then you use the software to generate data, right? Your Word documents and things. Artificial intelligence is the opposite, where you take data and give it to machines that build algorithms, and that in turn becomes the software. They build models. So if your data isn't great, guess what? Of course, you're going to get terrible results, terrible models, and things will just not work out well for you. So having that bedrock of solid data is so important to make data useful today and to set data as the foundation for your future. So let's talk about this data lifecycle. I'm actually going to bring this up here as a model. It looks complex, it's okay. This is the data lifecycle, the data processing lifecycle for how you take data and turn it into something useful. It is based, unsurprisingly, on the scientific method. Data science is nothing more than using the scientific method with your data. So let's begin here at the top with define. So the first thing you need to do with your data before you do anything else is define what problem you're trying to solve. What are the goals? What are the reasons you're doing this investigation? What is the question that you want to answer? What is the business impact you need to make? If you don't have those questions answered, if you don't define your goals, the data is not going to help you. It's just going to take up time and resources that you could be using for other things. So that's the first thing, probably the most important thing. Everything else is sort of execution. That really is the strategy part, and you've got to get that right. The next step is to ingest your data, and that means to essentially bring it in, to gather it. As public relations professionals, you've got a lot of data sources. You've got social media monitoring tools and regular media monitoring tools. You've got web analytics. You've got CRM, marketing automation data. You have traditional coverage. You have maybe closed caption data. So you've got to bring all this data into an ecosystem somehow. And typically for data scientists, you're going to be working with people who can deal in structured and unstructured databases. The easiest way to explain it is structured data is anything that goes in Excel, and unstructured data is everything else on your computer, like Word and the iTunes and stuff, all the stuff that doesn't fit in nice, neat tables. You'll want to differentiate that and then ingest it, bring it all into one spot, because the next thing you're going to do with that data is analyze it. And this is not analysis in terms of, okay, what answers does it give us? This is, what condition is this data in? Is it in good condition? Is it in bad condition? Are there issues with it? What's going on within the data? And there's really three things that can go wrong with your data. There can be data that is wrong. So you get data, say, out of, I don't know, your social media monitoring tool, and some of it is flat out wrong. You can get data that is missing. Data that is just not there, or there's gaps in your data. Maybe somebody removed your website tags from your website one day by accident, and you have missing data. And the third thing is you can get data that is structured incorrectly. You can't make an analysis of it. I was looking at some podcasting stats recently from this podcasting application, and they give you this data in this crazy table format that it's like tables on top of tables, and you have to basically undo that mess that they've made. So the next three steps in the life cycle are repair, clean, and prepare. So repairing is, of course, dealing with those issues of data being missing. Cleaning is fixing the data that's wrong. And then preparing the data is structuring it in such a way that you can analyze it. If you ever have dealt with healthcare data, for example, healthcare data is such a mess, particularly electronic health records, electronic medical records. I was looking at one EMR system recently, had like 70 different tables. In order for a lot of us to do our data analysis, preparing the data means trying to get it out of these 70 different tables and bringing it back into one big table so that we can run analysis on it. So repair, clean, and prepare are important steps in your data processing. For your average PR professional, again, it goes back to a lot of those services. Like you have your social media, and you have your media monitoring, and you have maybe some marketing data and some web analytics data. You're going to need to bring all that together, repair, clean, and prepare it for working with it. The next step in the cycle is called Augment. Augment refers to, okay, you've got all this data, but is the data that you have enough? Or are there other data sources that you need to bring in? You may need, for example, if you're doing social media analytics and you've got your brand's data or your client's data for what they did on Twitter, well, cool. Your client may ask you, hey, what about our competitors? So now you need to augment the data you've gathered with outside data sources. You need to bring in additional stuff. Another real good example is you've got your media monitoring for you and your peers, but you may be like, well, gosh, we see a big dip that we want to explain in our data. What happened? You may need to augment that with data from Google News, for example. What was happening in the world at that time that could have taken away mind share and eyeballs from your client or from your program? So augmentation is a really important step to bring in third-party data sources that you need. So that first third of the data lifecycle, that's going to be like 60 to 80% of your time. It is in data science, that is 60 to 80% of what most data scientists spend their time on is preparing data. And there's a number of software companies that are trying to make it easier, usually for very high prices. But in the end, there's always going to be a little bit of elbow grease involved in it. So just to set expectations, that part alone takes a lot of time. You can automate some of it, and you absolutely should automate some of it, but some of it's still going to require some elbow grease in the end. I would strongly encourage you, especially if you work in an agency, to look at automation solutions, to look at custom code, to working with a developer, because the last thing you want to do is take an account coordinator and just have them be a copy-paste person, right? That is a waste of a billable resource, and your bill rates for even the lowest person on staff are going to be $50, $75, $100, $125 an hour. Do you really want to spend $100 an hour of a client's money copying and pasting? Probably not. So look for solutions as much as you can to reduce the amount of time you spend bringing all your data together. So let's say in our fictional scenario here that we've done a great job of getting everything that we want to know about a client's program or our business's program, if we're in-house, into one gigantic spreadsheet. Great. What's the next step? The next step is to explore this data, to figure out what's in here. This is actually a separate discipline or subdiscipline called exploratory data analysis. And there are a number of packages of software that actually do this. There's one called Smart EDA that I use within the R programming language. There are off-the-shelf solutions. There are SaaS solutions like IBM Watson Analytics that can do a lot of the exploration for you. And what you're doing is figuring out what is the data, what's in the data, what things can we learn about it. And so you're going to look at basic statistics, like if you have a numerical column in your data, say like the number of retweets, for example. What was the minimum? What was the maximum? What was the median? What was the average or the mean? What is one standard deviation? You're starting to do mathematics on the data, on any quantifiable data, to see, okay, what's in here from an information perspective that we can make use of. It would be good to know, for example, the maximum number of retweets that your client had versus their competitor. It would be good to know that March is a better month for your client's Facebook posts than May is. So this is what you do in the exploration phase. You may not necessarily be tackling the questions that you set up when you defined your goals to begin with. Right now you're just trying to get a lay of the land in the data set itself. The next step is to compare. And now you're taking data and comparing it to other parts of the data set, or you may be comparing it to those augmented sources depending on how you've structured your data. But those comparisons and understanding what's happening period over period, for example, in your data is very, very important. And that process is a part that actually a lot of public relations practitioners leave out. So one of the things that I remember back in my agency days, I would see reports going out to clients, and we would see like, this is what happened this month. And the client would come back and say, this has no context, right? Is this better or worse than last month? So there's a time-based comparison. Or they would say, what's happening with the XYZ competitor? Okay, there's a qualitative comparison there of some kind. So comparison is an essential part of the process to help give context to your data. The next stage is prediction. And this is where we start to look at the data and forecast it forward. And there's two types of prediction you can use. You'll be doing either what's called driver analysis or time series forecasting. Driver analysis says, here's a KPI that we care about. What causes or what has a high mathematical relationship to that factor? So let's say we've got all of our data in one big spreadsheet. And in one column, there is a number of leads generated. Maybe it's a B2B example, or a number of shopping carts filled, like an e-commerce example, or a number of people who walked in the storefront for a B2C brick and mortar. That number is super important. If we have our data laid out in this big table, we can say, okay, well, what metrics leading up to that have a high mathematical correlation to the outcome. Maybe it's for storefront visitors. Maybe it's the number of people who visited the driving directions page on our website, or maybe it's the number of Instagram posts that somebody liked or commented on. What we want to do with driver analysis as a form of prediction is to develop that mathematical model. The second one is time series. So if we have again, storefront visits. We have 5 years of the number of people who walked in the front of our store or filled out a form on our website, or whatever the KPI is. You'd want to use time series forecasting to figure out, okay, what's likely to happen in the next 30 days or 6 months or a year. Depending on how much data you have to work with, you may be able to forecast that forward and make a prediction. Okay, it's August 2018 as I record this video. What's going to happen in October of 2018? I was doing a report recently for the women's footwear industry and forecasting for when is the exact week that the retail shopper is going to go out and say, all right, this is the week we're going to buy gold-colored pumps. I don't know anything about that, so I'm just making this up. But that forecasting is a form of prediction. It helps us predict and understand this is what's likely to happen. So in this stage, now that we've explored and compared our data and gotten context, sort of done our look backwards at our data, now we're going to look forwards, either with driver analysis to help us understand what drives those KPIs, or with time series forecasting to understand when a KPI is next going to do things. The next stage in the cycle is, okay, we've got our predictions. What prescriptions can we build from those predictions? So if I know that gold-colored pumps are going to be real popular the week of, I don't know, the third week in November, I can prescribe a recommendation from that. Okay, I can say, okay, so in that case, I want you to double your AdWords budget for the search keyword women's gold pumps, right? Okay, there's a prescription there. If I've done driver analysis and I find out that tweets and emails combined on the same day are the things that cause the highest number of conversions. Okay, great. I have a prescription. Let's double the number of tweets and see if we see a corresponding increase in that KPI. That's building a prescription. And we obviously, once we've got our prescriptions all written out for all these different types of analysis, that's essentially a model. We've built a model. We've said, I think there's a mathematical relationship between these things, and we've made these prescriptions. Now we're going to codify it into a model, and then we're going to go test it. This is the validation stage. If we think that tweets are on Tuesdays are the most important thing, great. We're going to tweet a lot more on Tuesdays. We're going to validate that model and prove or disprove that prediction. The prediction is a hypothesis. If you remember from science classes and you're assuming you didn't sleep through them, when we test a hypothesis, we test whether it's true or false. And so no matter what we're doing, whether it's driver analysis or time series forecasting, we want to understand, okay, is our prediction causative? This goes back to something that a lot of folks talk about in the statistics world. It's one of the core axioms of statistics, which is correlation is not causation. Just because something has a mathematical model relationship that we saw in the prediction phase does not mean it's got a causative relationship. So this is why the validation is so important. We can't just say, yes, tweets drive this thing, and so we're just going to tweet more and everything will be great. We don't know that for sure. We have to test. The textbook example that a lot of people give for understanding the difference between correlation and causation is if you look at a chart and you see over time, certain periods of the year, the number of people who drown, who die from drowning, goes up, and the number of people who eat ice cream goes up. Now, if you just say correlation is causation, then clearly ice cream causes drowning, but we know that's not true. From a common sense perspective, we know that certain times of the year it's warmer than other times of the year, and thus people will eat more ice cream when it's warmer and will go swimming more when it's warmer, which of course, unfortunately, a certain percentage of people do drown. And so by understanding that, we understand that's a case where there is no causation. And so if we were to increase the amount of ice cream people ate or decrease the amount of ice cream people ate, we wouldn't see a change in drowning. Likewise, with a lot of our marketing, a lot of our PR, a lot of our communications metrics, we need to prove that the relationship we see mathematically actually matters. So if we see emails driving more store visits, cool, okay, we've established the relationship. Now, let's send more email, send 50% more email. Does the number of store visits also rise by 50%? If the answer is yes, then we have established a causative relationship. And this is the validation phase. If the answer is no, then we know we have a relationship, but that we need to dig deeper. We need to maybe go back to the drawing board and say, okay, well, they're related, but we're missing something, kind of like the ice cream and drowning example. You're missing something. You're missing the season. You're missing the temperature outside as data that's missing. So if you increase the amount of email you send, for example, and your leads don't go up, okay, you're missing something. Go back to the beginning and figure out what data it is that you're missing. If we do find out that there is a causative relationship, that's when we refine the model. Bring in more variables, bring in fewer variables, test greater than a certain amount or less than a certain amount. We want to explore the limits and the boundaries of the causative relationship that we found. This is the refined stage of the data lifecycle. And we want to understand, okay, we can send 20% more email and get 20% more lift in leads, but if we send 50% email, we only get 30% more leads. So we want to understand the nature of the causative relationship and be able to explain it to people. After we've done all of this work to create a model and validate it and prove that it works and refine it, we're ready to deploy it. We're ready to roll it out to the rest of the client, maybe the rest of our team, maybe the rest of our agency, even if we're agency side, or the rest of our brand team if we're in-house. That's deploying the model, making it production ready, and getting it ready for business users. A lot of what we've talked about so far is very much work that data analysts and data scientists and marketing technologists would be doing. Now we want to figure out, okay, how do we take this and turn this into something that's usable for everybody, from the intern all the way to the CEO. That's deploying the model, and you may have different vendors and different solutions in place to do that. At the end of that, after the model is fully deployed and everyone is sending 50% more email because we know that's working, then we observe and we look for changes. We look for unusual behaviors that would indicate, yep, this is working, or no, something's different, something's changed. Hey, we're sending more email we're sending 50% more tweets on Tuesdays, and suddenly the response rate isn't as good as it used to be. Anyone who's done any kind of marketing on Facebook has seen this scenario play out a whole bunch of times. Hey, we're doing our thing on Facebook, and whoa, our reach is gone. Something changed. We observe, and that brings us back to the beginning of the process where we see, okay, we need to define our goals and our problem again. We want reach on Facebook, but our numbers dropped off. What's going on? And it begins the life cycle all over again. This life cycle is how you get to prove answers when you're working with your data, and it applies to any form of data that you're working with, any form of quantitative data, certainly, data that's measured numbers and percentages and things. It applies also to qualitative data to some degree, but with a little bit of refinement, particularly on the models and deployment. Is it intimidating to listen to all this? Yes, it can be, especially if there's a fair number of people who got into communications and public relations because math wasn't their strong suit. The reality is, though, that today everybody has to be able to do everything at least somewhat. The folks in the marketing technology community call this a T-shaped person, someone who has a lot of experience across a broad area and then one area of deep expertise. The latest trend has been what's called somewhat inappropriately, a fat T or a wide T, where guess what? You can't be specialized in one thing super narrowly. You need to have multiple specialties or have broad, deep experience. Although it's neurologically unsound, the analogy of left brain person versus right brain person, someone who's quantitative versus creative, is still an apt analogy for saying that you can't be left or right brained anymore. You have to be whole brained, or you have to hire enough people that you can compensate for where you aren't as strong. So if you're not strong at data, guess what? You're going to have to hire a data person or hire a data agency to do a lot of the data work while you focus on the creative. That's okay. It's okay if you're mid-career and you're like, I don't really want to go back and have to learn statistics again or try and pick up machine learning, but understand that you will have to have that capability either in-house or agency side in order to make the most of the data lifecycle. At the very least, if you do nothing else from this whole thing, understand that you have to be looking at your data. You have to be exploring it. That explore phase and understanding what's in data is the linchpin on which most everything else is important, because yes, that whole first process where you're starting to formally clean and prepare the data, if you're just getting a single export file out of Google Analytics, there isn't much preparation to do. Likewise, building prescriptions and stuff from the other side and modeling, again, if you've got a small amount of data, you may not necessarily need to do all that exactly along the process. You would at the enterprise level, but for like a single person solo practitioner working with one narrow set of data, you don't need the formal steps in such a rigid process that you can't be creative. But the exploration and compare and predict pieces at the bottom of this model are the most important skills to pick up, because that will tell you how anytime someone gives you a piece of a data set, okay, what's in here? Let me get some context for it, and let me build something from it. Those three skills are skills you need to develop. Now, the logical question is, okay, well, if I need to learn those first, how do I do that? Where do I start? You could take a data science course, and if you have that aptitude, I would certainly strongly encourage you to pursue that aptitude, because it's a very valuable skill set. If you don't have that aptitude, hire someone who does. Hire someone who does, maybe as a contractor or as an outside agency or consulting firm, or a full-time employee if you are running into that a lot. But you need to have that capability, that built-in analysis capacity, in order to make use of all the data that every industry and every profession is dealing with. The one other attribute that is not on here but encompasses all this at a meta level is curiosity. If you are not a curious person, if your client is not a curious person, if your CEO or your board are not curious people, none of this will matter, because without that desire to know more, to want to explain things and really explain them, not just accept like a 5-second answer or a bullet on a slide, but to really say, oh, why does this happen? Or what made this happen? Or how can we make this better? If you don't have that curiosity, you're going out of business, right? If you work for incurious people, update your LinkedIn profile and start looking, because that is a company that is not going to make a commitment to data. They're not going to make a commitment to data science, to machine learning. And the way the world is going, the way the industry is going, those companies that are curious, that are willing to test and experiment and be a little further ahead and be willing to fail at various projects, they're going to be the ones who are going to make bank. They're going to be the ones who are going to develop a competitive advantage that is so strong, that is so far ahead, that the early adopters will develop, in some cases, an insurmountable lead, unless they do something like horrific. They'll just blow themselves up, with self-inflicted wounds. A company that, if you look at like a Google or a Facebook or any of these behemoths, they have nearly insurmountable leads. The only thing that will bring them down is themselves. The same is going to be true across every industry. The company that embraces data and the data lifecycle across the board is going to have a nearly insurmountable advantage because, as we were talking about at the very beginning, data itself is an asset. Once you build models around it, once you build systems around it, that becomes valuable in and of itself. The sooner you start, the more data you accumulate, particularly when you do the cleaning process in the first part of the life cycle. And that means you have better models. That means you have better assets. That means you have a further head start that someone coming along later has to catch up to. And they may not be able to because you've got all the data from the time period before they got in the game. So the sooner you get on board with stuff like this and get it in place, the better your company is going to do. So that was a lot, and I recognize that was a lot. It's 26 minutes in. It's a lot to think about. It's a lot to consider. But this is part of the future of public relations. It's not the whole future. Again, left brain and right brain. Creativity is not going away. Empathy is not going away. Human judgment is not going away. Human experience, life experience is not going away. The human-to-human relationships that you build with your media sources, with your clients, with influencers, that's not going away. But if you only have half the pieces and a competitor has all the pieces, qualitative and quantitative, the competitor is going to win. So you need to be able to have all the pieces too. As always, thank you to the SpinSucks community and to Mike and to Jenny and the whole SpinSucks crew for having me and for this very, very long blog post. I look forward to taking your questions as you have them, and I'll talk to you guys soon. Take care. If you want help with your company's data and analytics, visit braintrustinsights.com today and let us know how we can help you.